Hey everyone, welcome back. Today in my video, I'm explaining about the partial pressure of oxygen, partial pressure of carbon dioxide at different locations with comparison to the atmosphere. Okay, in NCRT there is a small table given which is comparing between the partial pressure of oxygen and partial pressure of carbon dioxide at different locations like atmosphere and then alveoli and then the oxygenated blood, deoxygenated blood, tissue, that case. Okay, this I am explaining in a kind of schematic way, that is circulation system, the double circulation system. A brief explanation about this is already given in my previous video. The link for the same will be provided in the description. If you are not able to understand these terminologies here, or how I am drawing this, or how I have drawn this, if you are not understanding, that means you not understand the double circulation system of humans. So please refer that video, then you can come back to this to understand this. Okay, this video. Okay, now here first I will start with the atmosphere, the partial pressure of oxygen in the atmosphere, and then I will enter into the alveoli. Then passing through alveoli I'll come to the oxygenated blood, then to the tissues, and then I will end up with the deoxygenated blood. Okay, this is the way I am going. First, coming to the atmosphere. In atmosphere I will first deal with oxygen, then I will come back to carbon dioxide. Okay, in atmosphere the partial pressure of oxygen is 159. All the all the units are mm per hg only. Okay, mm per hg. I am not writing this all the time. Millimeters per mercury, that's the units. I'm not writing all these units all the time. I'm just writing the numerical value. Okay, the partial pressure of oxygen in the atmosphere is 159 mm per hg. Then next, coming to oxygenated blood, or after atmosphere we thought we'll do alveoli. So coming back to alveoli, the partial pressure of oxygen in alveoli is 104 mm per hg. Okay, here it is 159, and in the alveoli it is 104. The oxygenated blood starting from the alveoli is nothing but present in lungs. So starting from lungs through the pulmonary vein here carries oxygenated blood, and then it is receiving to the left atrium, then through the left ventricle, through the artery it is entering into the tissues. So all starting from here till tissues, all this side, that is including the left hand side, are the oxygenated blood that is carried out from lungs to the tissues. Okay, now here the partial pressure of oxygen in pulmonary vein as well as artery where the oxygenated blood is carried is 95 mm per hg. What is it? 95 mm per hg. Next, coming to the tissues. At tissues, partial pressure of oxygen is how much? 40 mm per hg. Okay, in oxygenated blood it is 95 mm, and then in the tissues it is 40 mm. Okay, next, coming to pulmonary vein. In pulmonary vein, in pulmonary artery and vein, pulmonary artery and vein. Here pulmonary vein is carrying oxygenated blood, here pulmonary artery is carrying deoxygenated blood. Okay, including pulmonary artery and vein where the deoxygenated blood is flowing, there the partial pressure of oxygen is 40, again 40 mm per hg. Okay, again 159 in atmosphere, 104 in alveoli, 95 in oxygenated blood, tissues may 40, and then even in deoxygenated it is 40. Now next, coming to the partial pressure of carbon dioxide. In atmosphere it is only 0.3, only 0.3 mm per hg is present in the atmosphere. Coming to the alveoli, what amount is present in alveoli is 40. Okay, then next, coming to the oxygenated blood, partial pressure of carbon dioxide is again 40 mm per hg here, where in oxygenated blood. Next, coming to the tissues. In tissues it is 45 mm per hg. Okay, here very careful, oxygen is 40 at tissues and carbon dioxide is 45. Okay, and then coming to here deoxygenated blood, again the partial pressure of carbon dioxide at deoxygenated blood is how much? 45. Okay, because we can, I remember it in this way, the partial pressure of carbon dioxide is more than that of oxygen. Why? Because the blood here after tissues, the blood whatever is formed is having more amount of waste in it. I can say more amount of carbon dioxide in it and less amount of oxygen. So oxygen partial pressure is low, and then the carbon dioxide partial pressure is comparatively less, comparatively more than compared to that of oxygen. Okay, once again, because the the deoxygenated blood is not carrying much of oxygen, rather carrying waste materials, and I am specifically let it be carbon dioxide, because more amount of carbon dioxide is flowing through the deoxygenated blood. That's why the partial pressure of carbon dioxide is more compared to that of oxygen. This is the way how I remember these values here, because this is the area where we get confused. Okay, even you can remember it as a table, but this schematic diagram is easier to follow and understand, to remember the concepts very easily. Okay, I if you want, you can take a screenshot of the same, and then you can revise it whenever it's required. Okay, I hope you all understood the different partial pressures in an easy way through this schematic diagram. Thank you so much for watching.